Speed mode is ideal for accurately controlling things like the speed of a spindle on a CNC or a conveyor that has to travel at exactly the right speed. In this video, we're going to get the speed modes up and running quickly using mostly default settings. To switch to speed mode, with the servo motor disabled, we just go to parameter 1.01 and change the mode digit to a 2 or a 4. We'll start with mode 2, and once we understand how that works, we'll take a look at mode 4. There are 3 ways you can control the speed of the motor. First, you can use a plus or minus 10 volt analog input to control the speed. That voltage swing is normally provided by the PLC or sensor that you're connected to. In this demo, we're going to use a 5 volt potentiometer across a 0 to 5 volt supply to keep things simple, and so I can show you how to scale the analog input. You can also filter it to minimize noise and help smooth the transition on fast analog voltage changes. The second way to control the speed is by selecting one of 3 preset speeds. The third way is to simply fill these guys in via comms. Check out the communications videos to learn how to do that. You can apply an S-curve to all of these, so when you switch from one speed to the other, you get a nice smooth transition, which prevents a sudden speed change from jerking your machine around. The analog input or one of the 3 presets are selected using 2 digital inputs. We're going to use digital inputs 9 and 10 in this example, wired as normally open switches with an external 24 volt supply. We need to tell the drive that's what they're being used for in parameters 2.36 and 37. Remember that the 2 rightmost digits are the function code, and the leftmost digit tells the drive we're using these as normally open switches. A 0 in that first digit would tell the drive we're using a normally closed switch. I'm not showing the wiring here to save space, but I also still have the servo enable, the alarm reset, the e-stop, and overtravel limits wired like they were in the quick start video. Those are all defaults, so there's no parameters to change for those. There's a low pass filter here to help reduce noise, and one final catch-all speed limit. Parameter 1.055 limits the max speed of the motor, which by default is the rated speed of the connected motor. So no matter what stupid thing you do back here, the motor will never be overdriven. We aren't going to use it in our demo, but I did want to make you aware it was available because you might want to set it to your max process speed to protect your system, for example. Now that's all we'll do in this video. We call this the command section, where we tell the drive what we want it to do. There's a whole other section that, given this command stuff, then tries to maintain the speed of the drive no matter what. That's where the gains and inertias and tuning and resonance filtering kinds of things are taken care of. That's the speed control portion. Given this diagram, enabling speed mode is easy. Here's a list of all the parameters from the previous diagram. I went ahead and did the factory reset and power cycle the drive, because you always want to power cycle the drive after factory reset to ensure any residual settings get cleared out. The blue parameters are factory defaults. So I then entered the remaining 6 parameters. Now this is important. You should also power cycle the drive whenever you change the mode so you're sure to have a clean start, and whenever you change the I/O functions. I assume that's because the I/Os are probably configured on PowerUp. Regardless, it's a good idea to do the digital I/Os last, so one power cycle covers anything you might have missed. The speeds are in RPM with 1 implied decimal place, so this is really 120 RPM. This servo is capable of doing thousands of RPMs. I'm intentionally keeping the speeds low here to make it easier for you to see them change in the video. And while we're not going to mess with it in this video, I did want to make you aware that you can enable torque limits and specify a different amount of torque for each of the 4 channels. We'll leave them at the blue defaults for this video, which is 100% of rated torque. You can also enable the torque limiting via a digital input, and you can monitor when torque limit is active with a digital output. Well, let's try it. I have these 2 selector switches connected to the digital inputs so you can see what's going on. Normally, these would be connected to your controller. Let's enable the servo motor, and I'll change the display to show the shaft speed in RPM. The 2 speed selector digital inputs are off right now, so we're looking at the analog speed control. If I rotate the potentiometer, yep, speed changes. If I rotate all the way to 5 volts, we see roughly 1500 RPM. Why? Because parameter 1.40 specifies the max RPM to be 3000 RPM at 10 volts. So the 5 volts we're giving it is at 1500 RPM. If I want 5 volts to give me 3000 RPM, I need to tell the drive 10 volts should give me 6000 RPM. So I'll go to parameter 1.40 and change it to 6000 RPM. Select that, and sure enough, we get 3000 RPM at 5 volts. Well, that's all there is to scaling. If I select speed 1, we get 6 RPM. Speed 2, we get the 60 RPM. And speed 3, we get the 120 RPM we asked for. Perfect. There is one problem. Suppose you want to use this analog channel as your 0 speed so you can have 0, low, mid, and high speed settings, for example. While trying to get an analog input exactly 0 is almost impossible. I don't know if you can see this, but when I rotate my potentiometer to 0, the shaft is still turning, and it's actually turning backwards. And that will drift over time and temperature, and someone can even bump the potentiometer. So, is there a way to guarantee this will be absolutely 0? Yep. Remember that we said there are 2 speed modes? We're currently using mode 2, which is the standard speed mode. If we set that to a 4, we get something called speed 0 mode. It's the exact same thing that we've been doing, except it breaks this connection and forces us to a true 0. Of course, scaling and filtering don't do anything when the speed's 0, so these aren't necessary in this mode. Again, just set this to a 4 and you have speed 0 mode. So I'll disable the motor, change parameter 1.01 to a 4, and the display reminds us to do a power cycle. Remember, we always need to power cycle the drive after a mode change. Now if I enable the motor, the speed potentiometer does nothing. But the other 3 digitally selected speeds are still working. Perfect. The S-curve option lets you specify how smooth the transition between speed changes will be. Parameter 1.34 sets the acceleration time, parameter 1.35 sets the deceleration time, and parameter 1.36 sets the smoothing time at each transition. These are independent, so you can have a 0 transition time and still set the acceleration and deceleration times to create just a regular trapezoid if you want to. And notice that this affects the analog speed transitions too. And finally, you can remove the high-frequency noise using this low-pass filter. You may ask, what's the difference between this filter and this one? Well, this one is a straight low-pass filter, which means it rounds off the sharp corners. This one is a moving filter or averaging filter, so it smooths everything. In general, you want to use the low-pass filter if the commanded speed is coming from a position command, a point-to-point move. Use the moving filter if the commanded speed setting is only for the speed control. That'll give you better smoothing. They both create delays and make your system less responsive, so always keep any filtering you add to a minimum. A 0 for either of these turns filtering off. Well, that ought to be more than enough to get you started with speed mode. And while speed mode is simple in concept, there's a lot of stuff going on under the hood that's required to optimize your system. The good news is, AutoTune does an amazing job of taking care of all of this, so you really never have to worry about it. Could you tune it manually yourself? Sure. But if you watch this AutoTune video, you'll quickly realize that most of the time, there is absolutely no point in doing it manually yourself. AutoTune takes full advantage of the drive's 3.1 kHz bandwidth to produce optimal results for you. Meanwhile, click here to learn more about the SureServo 2 system and how to find more videos. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos like this, and click here to learn about Automation Direct's free award-winning support options.